Oh, it's example 4. Check that thing.
You guys ready to rock?
And roll.
And roll. Here we go. Right equation for polynomial solutions 4 and I. What we did yesterday is we said, hey, we've got this polynomial 8x cubed plus 1, and we found the solutions. These were the solutions, right? Today what we want to do is we want to take the solutions and write the original polynomial. Okay? So we're going to use the fundamental theorem of algebra parts 2 and 3 here. It says write equation, so I have p of x is equal to. And if 4 is a solution, then what's a factor? X minus 4. And if I is a solution, then what's a factor? X minus I. Fundamental theorem of algebra part 2 says everything factors, and you can simply write it as x minus whatever the solution is. But the fundamental theorem of algebra part 3 says that if there's an imaginary solution, they always come in pairs. So if I is a solution, then so is negative I, the conjugate, So therefore you have x plus I. How about that? So let's go ahead and let's multiply these out, okay? We get p of x is equal to x minus 4 times, we have an x squared, we have a positive xi, we have a negative xi, and then negative I times I. Negative I squared, which Mr. Palmer says is a positive 1. He is correct. Notice in this process that the positive xi and the negative xi disappear. So we have p of x is equal to the x minus 4 times, we have an x squared, and then we have a plus 1. Any questions how I came up with that? In order to write in form of a polynomial, we now multiply that out. P of x is equal to x times x squared is x cubed. Negative 4 times x squared is negative 4x squared. X times 1 is x. And negative 4 times 1 is negative 4. What do you think about that, Ben Schultz?
Wowzers.
He says wowzers.
I do.
Last problem of the unit, chapter 3, basically done. You guys almost have earned your 3 college credits for this class. Congratulations. Write an equation for a polynomial with solutions negative 3 and 4 minus 2i roots of 3. P of x is equal to, how is this going to start? X plus 3 times what? Good. The man that's whispering says 4 minus the quantity 4 minus 2i roots of 3. And if 4 minus 2i roots of 3 is a solution, then so is 4 plus 2i roots of 3. Now, people get used to changing this first subtraction sign. We don't do that. It's x minus. It's always x minus. And here it ends up being 4 plus 2i roots of 3. I'm going to take this grouping right here. I'm going to distribute the subtraction signs. I get p of x is equal to x plus 3, x minus 4, plus 2i roots of 3, x minus 4 minus 2i roots of 3. Kind of like we did in the previous one, I would like to multiply out those imaginary pieces. And notice in the previous one, the imaginary pieces just disappeared. That's going to also happen in this situation. But just be ready that there's going to be a lot of terms here, because if you have 3 times 3, we get a total of 9 terms. That's going to be a lot of work. So we will be patient. We'll distribute the x through to each term. We get an x squared. Negative 4x. Negative 2xi roots of 3. It's the first time we've ever written something like 2xi roots of 3. It's okay. What should happen to it anyway? It should cancel with something, because we know those all disappear. Then we move on to the negative 4. We have a negative 4x. We have a positive 16. And we have a positive 8i roots of 3. And then we move along. 2i roots 3 times x is positive 2xi roots of 3. 2i roots 3 times negative 4 is negative 8i roots of 3. And then you have this last piece. I'm going to write it 2i roots of 3 times negative 2i roots of 3. Got to multiply that out. What's negative 2 times 2? Negative 4. What's I times I? I squared, which is negative 1. And the root of 3 times the root of 3? 3. So you end up with negative 4 times negative 1 times 3, which is 12. Woo! What do you notice?
Some stuff cancels.
Yeah, some stuff cancels. Negative 2xi roots of 3, positive 2xi roots of 3. 8i roots of 3, negative 8i roots of 3. So we have p of x is equal to that x minus 3 times, we have an x squared. How many x's do you have? Negative 8 x's. And then 16 and 12 make 28. Hen, is Leonardo DiCaprio, is that your celebrity crush?
No.
Oh, okay.
It's mine.
He's yours. Okay, got it. All right.
Yeah.
He's got a new movie out, doesn't he?
Oh, yeah.
It's a Martin Scorsese movie.
Killers of the Flower Moon or something like that.
Okay.
It's 3.5 hours long.
Have you seen it?
I've heard it's good. No, my dad saw it.
Okay. A lot of violence.
Yeah.
Yeah. Martin Scorsese. So.
He said it was really good and pretty thrilling, kind of mystery.
Okay. Because I want to watch it.
No, it's a long movie. It's a sit down for sure.
So my eye, got something in my eye. I got eyelashes. Kind of buggy.
Watch a movie.
I will admit that's kind of good. I don't know. If it's 3.5 hours, would you rather watch it in the theater or would you rather just watch it at home?
Home, for sure.
I'm thinking maybe home.
And you can take a bathroom break and pause instead of missing something.
Yeah, amen to that. Or like go get some ice cream.
Yeah.
Because I like the movie theater, but like the food there and stuff is very expensive. You know, stuff in my house is cheap.
You gotta wrap it up in a blanket and take it in with you.
Oh, I'll get a blanket.
Wait, am I tweaking what you had? X minus 3. I thought it was X plus 3.
Yeah, x plus 3. Sorry
I
about
want
that.
to make sure before I had lost or something.
All right, I'm going to multiply all these by x, and I get x cubed minus 8x squared plus 28x. And then I multiply them all by 3. And I get 3x squared. I get negative 24x. And my 5th grade teacher told me that 3 times 28 is 84. And as I combine all the like terms, I have an x cubed. I have a minus 5x squared. I have a plus 4x. And I have a plus 84. Bada bing, bada bam. Piece of cake, upside down. You are done with Unit 3. That's it. You have your study guide. Answer keys are posted. I am here to help. You got lots of time to work. Half an hour. Make great use of it.